Good morning, good afternoon. This is a presentation on mobile hydraulic cranes. My name is Shane Holder. This is for English Technical Communications Information Presentation. I did choose mobile hydraulic cranes. It's something that I work with every day on a daily basis, lift plans, run cranes, and teach people how to operate, and also do have a class that's taught through NCCCO to get your crane certification classification for fixed, swing, lattice cranes, all sorts of different certifications they got out there for cranes. So I help out with that. This is a basic presentation on mobile hydraulic cranes, and we'll go over certain parts about the cranes. Some of the main parts of a mobile hydraulic crane is the lower structure. You also have the upper structure, your outriggers, counterweights, the main boom, and to name a few subparts, you have outrigger pads, axles, and the maneuverability. Talking about the wheels and how the axles can shift back and forth when you're on a job site. Your lower cab, mostly for driving on the road, and your upper cab, and then your main boom cylinder, boom extensions and jibs, and wire ropes. And then also you have blocks, and there's several different type of computer systems that are involved in mobile hydraulic cranes. So for the first one here, your lower structure, and this is just breaking it down very easily. It's generally where the driver cab is located, and it supports everything that's going to be above it. So the lower structure is on the bottom there, and you're going to use the lower structure to travel on the roads, travel on a job site. Upper structure is everything above the lower structure, and this is going to have your boom, your main boom cylinders, your counterweights, your upper cab, and there's computer systems on both sides. But most of the time when you're talking about operating a crane, everybody's talking about the upper structure. The computer cab has a crane in there, and that's how you would set up a crane. Your outriggers, they're extended out. The whole purpose of an outrigger is to extend out your crane so that you have more structural stability. If you think of a crane like a fulcrum, if you're able to push your outriggers out more, it makes it harder for it to tip over. So the whole purpose of having outriggers is to have a more stable surface for it to set up on, make it so you don't tip over as easily. There has been a lot of accidents in cranes where operators have not pushed the outriggers out and set the pads down onto the ground, and it causes the crane to lose stability and tip over to the side or backwards. The counterweights itself, these are added and removed as needed. Some of the smaller cranes, 30 ton, 40 ton, even maybe up to a 60 ton, they don't come with any additional counterweights, and so they're not removed or taken off. It rides as it is, and that's how it comes. If you get up into 200, actually 165 ton and up, maybe 115 ton and up, they're going to start adding more counterweights to the back there, and these come in different increments. If you work with a Liebherr crane, they come with 25,000 pound counterweights that you can add to each side, and you want to add them evenly. And there's setup books for that. There's assembly, disassembly directors that get involved and to make sure that you're setting up a crane correctly. And so counterweights can be added and removed to increase that leverage on the crane side. So thinking of the crane again as a fulcrum, if you put more weight on your side, you can pick up more on the other side. So counterweights are really important to stability of the crane. The main boom is exactly what it is the main boom of the crane. They come in different sections. You have your base one, and then inside of the base of the crane, sections start coming out, and you can have up to 4 or 5 or 6 different sections that come out of the main boom to extend the boom out further so that you can reach further, and you can also take things off of higher buildings. Outrigger pads. These are on the end of your outriggers, and these go straight down. The outrigger goes straight out horizontally, and then for vertical lift, the pads are used to lift the crane off the ground. And most of the time you want to just basically take the weight off the wheels, off the lower structure, and put all the weight on the 4 to 5 different outriggers that the crane has. Underneath the pads themselves, they also have outrigger pads. They call it cribbing and blocking, or mats. And these just allow you to have more surface area. If you just use the pad itself, depending on the ground stability, you could punch through the ground and cause the crane to tip over. So having a mat or a pad underneath your outrigger pad is really important to have. Axles and maneuverability. So the cranes are pretty heavy. They can weigh up to 140,000 just without any counterweights, just the truck itself. Sometimes the booms are taken out so they can travel on the road, but it all depends on the state that you're traveling through. You need to have a certain amount of axles for that amount of weight. Most time the states want 20,000 pounds per axle. So if a crane weighs 140,000 pounds, you're going to have about 6 different axles there. The crane in the pictures there, you can see one that has 6 and then another one that has 5. The smaller the crane, the less axles are needed. And then if you only have a certain amount of axles, you might not be able to put counterweights on the back because you don't have enough axles, or it might put too much weight on an axle. So the axles itself are very important for traveling on the road. Maneuverability, you get into larger cranes, the axles are able to rotate left and right and able to either push the back end of the crane around or the front end, or travel the entire crane crab style where it completely goes sideways, which is something you can't normally do in a car. So it's really important for larger cranes to do this so that they can get into a spot and set up on a job site. The upper cab itself, this is where the meat and the gravy is. This is where the operator gets up in there and he sets up his computer, and he's going to use controls in the upper cab. They also have an operator seat, and there is different types of gauges you look at, depending on the crane you're into, you can also tilt the cab, and there's many other features. But this is where everything happens. When you're working on a job site, you're going to get up in the upper cab, set your computer up, push out the boom. They call it scoping, and you set up the crane according to what you're going to lift. The lower cab is what you're going to use out in town or maneuvering on a job site. It contains the steering wheel and the brakes and different operating systems, and also the lower cab has its own computer systems as well. The main boom cylinder, there is only possibly one. Sometimes in larger ones they have 2, but that thing is allowing your crane to boom up and to boom down. So it's putting out a vertical to a horizon type of plane, just up and down. That's all it does. And if you look at it kind of like a builder square, it goes from 0 up to 90. In larger cranes, they actually go less than 0 degrees. They can go down to like -5 degrees, so that if you're setting it up and you're putting extensions or jibs or other things on there, you're allowed to do that at a lower angle so that you're not having to get up on the ladder and knock pins in and everything. Boom extensions and jibs. These just make the main boom itself taller. So if you're working on a very tall load, erecting a tower, putting something on a building, the jibs and extensions allow you to get a little bit higher than normal. And there's other parts that are involved in this, but just to break it down easily, boom extensions and jibs just extend the height of your crane there, so you're able to reach stuff at a higher radius. and sometimes the jibs can be used to boom down and reach further stuff that is high and further. So all cranes have wire ropes. They're on a winch, and wire ropes themselves, to put it easily, they're a bunch of strands of wire that are woven together with other strands, and that creates the wire rope itself. There's always a core strand in the middle, so there's inspections that are done on these to make sure that they're not breaking, and there's different criteria to keep these things in service and going. The blocks, these come in different sizes. They can be there's a ball all the way up to 100 ton, 50 ton, just depends on what size of loads that you're picking up. So that there's on every block there's a hook, there's a retaining pin, there's sheaves, and there's wire rope that runs over the boom and down and under and over these sheaves and back up to the crane and back down. So the sheaves on the block are very important because it allows it to rotate smoothly around the block without causing any issues. And you want it to run smoothly so that you're not jerking and moving and making weird movements as you're lifting loads. Computer systems themselves, there's tons of these. I've worked with Liebherr cranes and Groves, and the computer system that's found in the upper cab and lower cabs it's not just something you can see visibly. Sometimes if you go on the sides of the cranes and open up different doors that they have, these things have supercomputers in them, and they allow to do different stuff. Troubleshooting, if a crane gets stuck in a certain situation, you might have to call technical support, and they'll walk you through changing pins out, changing different wires. It can get very complicated, and sometimes if the cranes are abused, these computer systems send stuff to the manufacturers to let them know, hey, this crane was misused and abused, and it might void a warranty. So some of the basic computer systems in there, there's anti-two box, allows you to cable up the wire rope with the block on it. It allows you to cable up only so far, and then once it gets to a certain point, there's a physical block that it hits, and it shuts down the crane so that you're not running the block into the boom itself and causing it to break and fall and possibly fall on somebody. So very important to have an anti-two block on there. Load moment indicators, they shouldn't be relied upon, but they do tell you up to 75% of the crane's capacity of what it can pick up. So a load moment indicator, LMI, is telling you what you're allowed to pick up at that certain distance at that certain time. Also, there's boom length indicators, tell you how far out your boom is going, and boom angle indicators. Sometimes there's a physical one you can see on the side of the crane, and you look over and you see, hey, it's at 20 degrees, 30, 40, 50, 60. And then also in the computer itself, it'll tell you, hey, this is what angle you're at. So also I did mention that there's range indicators on there, so boom angle indicators and range indicators. So that's the end of this technical communication here. Technical information presentation. This probably raised a lot of questions. There's a lot of information I didn't cover on here, but it does give you a general knowledge of mobile hydraulic cranes. Thank you very much. Have a good day.